last part, C, says, suppose that f is defined for all real numbers and is periodic with a period of length 8. The graph that we have up above shows 2 periods of f. So given that g of root 8 is negative 12, I want to find g of regular 8 and then write an equation for the tangent line at g at x equals 6. So this has a lot of stuff built into it. The first thing we want to do is find g of 8. Well, based on the original definition, that would be the accumulation from 0 to 64 of f. And we'll go up and look at this graph and see what that means. So up here, g of x was 0 to x squared. So if I plug an 8 in, I'm accumulating from 0 to 8 squared, or 0 to 64. So we got to think about what happens if I accumulate from 0 to 8. If I accumulate from 0 to 8, this triangle accumulation above will cancel with this one below. Same thing with this one below and this one above. So really the accumulation that we get, if we go all the way to 8, is going to be negative 12, because we have 1, 2, 3, 4 times 1, 2, 3, and it's underneath. So we know that accumulating from 0 to 8 is going to give me negative 12. So that 8, if we took the square root of it, would give me that root 8. So g of root 8, there's where that negative 12 is coming from. So if we now want to extend this to 64, we're looking at repeating this process all the way to 64. So we've got to think about how many times are we going to repeat this panel in order to get out to 64. Well, in order to do that, we've got to think about how many times 8 will go into 64 and whether or not there are any leftovers. And it turns out there are no leftovers. So it's going to take 8 repetitions for me to get to 64, and each repetition is going to be accumulating negative 12. So down here we can get that this will be 8 of the accumulations from 0 to 8, which will be 8 times that negative 12, or negative 96. So there's 1 point for that. The next 3 points come from getting that equation of the tangent line, and we can't get it unless we know g of 6 and we know g prime of 6. So let's think about how we could get g of 6. G of 6 is going to be the accumulation from 0 to 6 squared. So if we think about panels of 8 that we're going to be accumulating, I can fit 4 full panels, and then I'll have 4 left over. So accumulating from 32 to 36 is going to be just like accumulating from 0 to 4. So we already know that this accumulation is negative 12. Now we need to add the accumulation from 0 to 4. Well, we figured out the accumulation from 0 to 4 right here when we did part A, but you could also look at your picture. We accumulated from 0 to 4. These two triangles canceled each other out, and we had this negative 6 accumulation. So down here we will have the 4 times the negative 12 plus the negative 6. So I get a negative 48 plus a negative 6 gives me a negative 54. So that is my point, which is 6 comma negative 54. I also need my slope, so I need g prime of 6. So that means I'm going to go to my g prime, which was, if you go back up above, it's going to be f of 6 squared times 2 times x, which is 2 times 6. So I'm going to get 12 times f of 36. Now, because of the periodicity, 36 is going to be 4 units away from the start of the panel. So that will actually be 12 times f of 4. And if we go up and look at our picture, and remember that f of 4 is going to be in the same location as f of 36, if we repeat that panel multiple times, then we can see that the y-coordinate that will come out at 36 is the same as the y-coordinate that comes out at 4, which is negative 3. So I have 12 times the negative 3, which gives me negative 36. So now I've got the point and I have the slope. I can write the equation of the line. So the line in this case will be y equals the slope times x minus the x coordinate plus the y coordinate. And we're done. 1 point for the point, 1 point for the slope, and 1 point for the line.